In this presentation, we will discuss linear curve force through zero. According to Perkin-Elmer WinLab 32 help, linear force through zero forces the curve to go through zero intensity and zero concentration. The use of the relative standard deviation of calibration factor automatically forces a straight line through the origin. RSD is explained in the calibration factor response factor presentation. When we review NIST's explanation of linear force through zero, we see that NIST takes a cautious approach. NIST infers that forcing through zero may not be applicable in all situations. One has to use judgment. For example, when there is a considerable amount of intercept, forcing through zero will result in inaccurate results, especially at the lower end of the curve. Method 8000C goes on and states to not include the origin 0, 0 as an extra calibration point. However, most data systems and many commercial software packages will allow the analyst to force the regression through the zero. Forcing the curve through zero is not the same as including the origin as a made-up point in the calibration. In essence, if the curve is forced through zero, the intercept is set to zero before the regression is calculated. This setting favors the low end of the calibration range. This is accomplished by swinging the function around the origin to find the best fit and thereby resulting in one less degree of freedom. 8000C further states that it may be appropriate to force the regression through zero for some calibrations. This model does not allow reporting below the calibration range. The lowest standard is used to denote the reporting limit. If it is necessary to report results at lower concentrations, then the analyst should run a calibration that reaches those lower concentrations. For linear regression through zero, the calculations are performed as illustrated in the least squares regression presentation. To determine the slope and intercept, all the concentration and responses, which are either positive, negative, or zero numbers, are entered for each level. Benefits. 1. Simple. Calibration can be represented by y equals mx because the curve intercepts the y-axis at 0. 2. This model works when the origin 0, 0 is within the error of the measurement. Disadvantages. 1. This model does not work unless the slope is the same at all points. 2. This model also does not work when there is a high blank value because the responses are offset by that blank value from the 0 point. In the EnviroQuant software, there is a flaw with the linear force through zero calibration model with the R-square calculation. As demonstrated in this slide, even though the quantitation line is moved drastically away from the actual standard values because of the forcing of the line through zero, the R-square did not change. The reason for this is that the R-square is still being calculated based on the relationship of the points without 0, 0. This means that EnviroQuant is not a reliable software for use with linear 0, 0.